Next question asks, how long would it take for a motorcycle traveling at 90.0 kilometers an hour to cover a distance of 27 meters? All right. So when they ask how long, well, they're asking for the time, right? How much time has gone by? Okay. And they provide 90.0 kilometers an hour. That is a velocity. This is actually, it's not a velocity. It is a speed because they don't provide a direction. So it's just V. Okay. And the distance that they provide here, they even tell us that it's a distance, is 27 meters. All right. It's not displacement. They didn't give us a direction at all. All right. And we can still use the same equation, which is speed is equals to distance over time. All right. So this is speed. Speed is measured in meters per second. This is displacement or distance. We'll say distance because it is not a vector quantity. Distance in meters. And time we measure in seconds. All right, so let's write down our givens. They provide us with speed, which is 90.0 kilometers an hour. Okay. They provide us with a distance of 27 meters, and we are looking for a time. All right. Well, let's look at our givens and let's look at the equation. Is there something wrong? Do you guys notice anything? Well, our speed is provided in kilometers an hour. But in the equation, in physics and with SI units, you want to use meters per second. So how do we convert this? And I feel like a lot of students get confused when it comes to the converting of units here. So I'm going to do a quick aside here and show you guys how to do it the easy way. This is the way I like to do it. Okay. And all it requires is for us to multiply. Okay. So let's choose which one we want to do first. Are we going to convert the kilometers to meters or the hours to seconds? Well, let's do the hours to seconds first. Okay. And what I like to do is I like to multiply by a ratio. So I ask myself, well, how many hours in a minute? Because I can go from hours to minutes and then minutes to seconds, and it's super easy step by step. All right. Well, in 1 hour, that gives me 60 minutes, right? There's 60 minutes in an hour. So that's the ratio for it. And fractions are just like ratios, right? And what I do is I try to cancel out the hours and leave minutes. So I want minutes on the bottom then, and I want hours on top. Hours on top. Because in that case, the hours will cancel out, okay? So there's 1 hour in 60 minutes, or 60 minutes in an hour. And I just fill that in like that, okay? That's the ratio. And I cancel out the hours. Awesome. Next step is to go from minutes to seconds. Well, we want to cancel out the minutes. We also know that in 1 minute, there are 60 seconds. Okay. You can also just write S. That works too. So there's 60 seconds in 1 minute. And I wrote it like this with the minutes on top because I want the minutes to cancel out and I need the seconds on the bottom. Okay, because it's per second. In our final answer, we're aiming for meters per second. Right? So there we are. Okay. So right now, if we just look at everything, we have kilometers per second. Well, we want meters per second, so let's do another ratio here. Now I'm going to ask myself, how many meters are in a kilometer? In 1 kilometer, we have 1,000 meters. Okay. Do I want the kilometers on the top or the bottom if I need to cancel that out? Well, in the end, I want meters on top as well, right? So let's put meters on top, 1,000 meters, and kilometers on the bottom. And that way, as you see here, kilometer cancels out. And overall, the ones that aren't canceled out, well, I got meters on top and seconds on the bottom. So we just successfully converted 90 kilometers an hour to whatever meters per second all this would give me. And all I have to do is plug it into my calculator. So I'm doing 90 divided by 60. I divide by 60 again. And I take that and I multiply it by 1,000. And that gives me equals 25 and it's meters per second. Okay. If you do it this way, it is more or less guaranteed that you're not going to have a mistake if all of your conversions are right. All right. So 25 meters per second. And I can write that in here as well. 25 meters per second. All right. And now we're ready to use these numbers because we got velocity meters per second, distance, or sorry, not velocity, but speed in meters per second, distance in meters, and we're going to look for time in seconds. So our equation, V is equals to D over T. We're looking for time. So let's multiply time on both sides. TV is equals to D. We need T on its own, so let's divide out V. And we are left with T is equals to D over V. Awesome. And now we just have to plug some of our numbers in. I'm just going to go here to the right. So T is equals, our displacement is 27 meters. And our, sorry, not displacement, our distance is 27 meters. And our speed is 25 meters per second. All right. And now all that's left is for us to plug it into our calculator. If you really want, you can leave it as a fraction, 27 over 25. You can also just leave it as an improper fraction. That's totally okay in physics. Or we can also convert it as a decimal, which is 1.08 seconds. Okay. And we can go back and check significant figures. Speed was provided to 3 sig figs. Distance was to 2 sig figs. So we round it to the lowest number of sig figs, which would be 2 sig figs. And that gives us a time of approximately 1.1 seconds. Okay. And I'm putting a dot on top of the equal sign because it's a rounded number. You can either do the equal sign with the dot, or you can also do the squiggly equal sign. I've seen teachers more often accept both. And I'll box off my answer. All right, I hope this video helped.